Welcome all the students in my YouTube channel Physics by TC Chauhan sir. It is Airforce special now. Recently you have listened about coronavirus. It is very dangerous and harmful. But if you are at your home and you want to study, then it is best way to get support from our YouTube channel, and it is very beneficial for upcoming examinations of Airforce. Today we are going to discuss about thermodynamics. Student, you do like, share and go to comment section and like our YouTube channel. Let us discuss about thermodynamics and several questions based upon it. Students, thermodynamic itself is a major portion for the Airforce examination. We are going to discuss about thermodynamics, short questions, logical questions, numericals, etc. What does it mean by thermodynamics? Thermodynamics is a study of thermal flow or flow of heat from one place to another place. The first question is, what does it mean by heat given? Heat given is also known as enthalpy. It is delta Q is equal to mCp delta T. The next question is, on what factor does heat given depend? Heat given depend upon the factor Cp, that is specific heat at constant pressure. It does depend upon the change in temperature. The next question is, what is work done? That is delta W, that is P delta V, or W is equal to integral P dV. It is very important. The question arises, if volume is constant, what about work done? It will be 0. Remember. The another question is, if pressure is constant, what about work done? Then it will be there. It will not be 0. Another question is, what are thermodynamic coordinates? There are basically 3 thermodynamic coordinates: pressure, volume and temperature. What about thermodynamic equation? Equation is depending upon these coordinates: pressure, volume and temperature. F of P, V and T is equal to 0. Now another question. Another question based upon first law of thermodynamics. What is first law of thermodynamics? That is delta Q is equal to du plus delta W. Another question is, on which conservation it follows? It follows on the basis of conservation of energy. Another question is, heat given delta Q is divided in either 2 equal parts or not. It is not essential that these parts are equal. Now another question is, if work done is 0, then what about heat given? The heat given will be equal to change in internal energy. Now what about the another question which is based upon the second law of thermodynamics? The question is, short question is, what is other name of second law? Other name of second law is the principle of refrigeration or principle of heat pump, which is reverse of heat engine. Now what about the second law? Second law is given on the basis of 2 different statements, which are Kelvin-Planck and Clausius statement. According to Kelvin-Planck, it is impossible to get continuous supply of work and reducing temperature subsequently. Second is Clausius statement. It is impossible to transfer heat from low temperature system to higher temperature system automatically without help of any external device. It is not possible. This is second law. Now the question arises that what is entropy? Entropy means irregularities which are continuously going to be increasing. This is also known as third law, that entropy of world is continuously going to be changing. Entropy is continuously increasing. Now another question is, what about the slow process? It is isothermal. Remember students, it is isothermal process. Which is slow process? Isothermal. Which is fast or sudden process? If slow is isothermal, sudden is adiabatic. Adiabatic process is fast or sudden process. Suddenly, if something happen like bursting of tube, that happens suddenly, blast of bomb, that happens suddenly. These all are adiabatic process or adiabatic system. Now what about the condition? Condition of isothermal process is temperature should be constant. What about adiabatic? According to the condition, delta Q should be 0. Heat should neither be given nor be taken. That is the process of adiabatic. That is the function of adiabatic. Now, what about the curve of adiabatic, and what about the isothermal or adiabatic equation of state? These are equation of state of isothermal is PV is equal to constant, and the equation of state for adiabatic is PV raised to gamma is equal to constant. Remember, these are very important. Now, what about the curves? Isothermal graph or isothermal curve, that is PV graph is in this way, and that is PV graph is in this way for adiabatic. These are curves, or these are adiabatic and isothermal graphs or curves. This is also very important. What about their slopes? Slope of isothermal graph is tan theta is equal to minus P upon V. And what about this? For adiabatic, its tan theta will be minus gamma P upon V. Now the question arises, what is relation between them? It subsequently proves that the adiabatic graph is having slope gamma times that of isothermal graph. It means its slope is more than that of isothermal slope. Now, what about the other thing? Other thing is, what about the work done of isothermal? Isothermal process has work done 2.303 nRT log 10 base V2 upon V1. Remember, and what about work done in adiabatic? Adiabatic work done will be W is equal to NR upon gamma minus 1, T1 minus T2, and T1 is high temperature. These are basic difference between the work dones. Its work done highly depend upon temperature. Its work done highly depend upon change in volume. Remember, because here temperature is constant. Now, what about the graph which is drawn for different slopes on together, like PV graph is there? If it is drawn in this way, then how will you identify this graph is A, this will be B? Which will be isothermal, which will be adiabatic? Remember, this is isothermal, and remember, this is adiabatic. So these are isothermal and adiabatic. If you have to identify the graph, if the graphs are given in this way, how will you identify? Listen, the lower graph is said to be, it is PV graph, lower graph is said to be adiabatic, and upper graph is said to be isothermal graph. So these are important curves regarding to Airforce examinations. Now, what about the process in which neither heat is given, that is delta Q is equal to 0, neither work is done, that is delta W is equal to 0, then change in internal energy will be 0. This will be isolated process. The question arises that what is relation between different systems? If any process is cyclic, then which can be compared with it? Cyclic process is that process in which change in internal energy will be 0. That means it is just identical to isothermal process. Now, the question arises, what about the engine? There are two kinds of engine basically. First is heat engine, and second is Carnot's engine. Remember, heat engine is that engine in which the heat given and heat taken are important for work done Q1 minus Q2, and the efficiency of this engine will be ratio of work done and heat given. Carnot engine, it is an ideal engine of ideal condition having efficiency 100%. It is a theoretical engine. It is not possible to get 100% efficiency for any engine which is applicable or which is practically exist. But it is a virtual engine in which in this engine two ideal conditions are taken. One is ideal source of very high temperature whose temperature cannot be decreased, and another is very low temperature system whose temperature cannot be increased. then efficiency will be eta is equal to 1 minus T2 upon T1. Its efficiency will be 100% if and only if the T2 should be 0 or T1 should be infinity. These are the conditions on which Carnot engine work. Now another thing is, what about heat pump? Heat pump is just reverse of heat engine. Here we have to do external work and then heat is supplied from lower temperature system to higher temperature system for this purpose to get external work like refrigerator, AC. These works on the principle of heat pump. It is the complementary of second law of thermodynamics. Now students, we discuss about heat and temperature. What does it mean by heat? Heat is in the form of energy. It is directly proportional work done. H is equal to W upon J. J is Joule's mechanical equivalent of heat. Any heat is given by heat is equal to Q is equal to ms delta theta. Delta theta is nothing but change in temperature. M is mass, S is specific heat. Sometimes the important question can be asked, what about a specific heat? Heat required to change the temperature of 1 gram substance by 1 degree Celsius or unit mass substance by unit degree Celsius, that is specific heat. It is of two types. One is Cp and other is Cv. Specific heat at constant pressure and specific heat at constant volume. These have particular relation. Cp upon Cv is equal to gamma. Gamma is known as specific heat ratio or adiabatic constant, which is used in adiabatic process. Now, what about a relation between them, that is Cp minus Cv is equal to R. R is universal gas constant and this relation is known as Maier's equation. It is also important. Now, another question is, what about latent heat? Latent heat is heat required to change the state either from solid to gas or from gas to liquid. Now, what about latent heat of fusion, LF? That will be M into LF, that is given by Q. What about LF? LF is 80 kilocalorie per kg for water. It is latent heat of fusion. What about latent heat of vaporization? If liquid change from liquid state to gaseous state, then it is latent heat of vaporization. It is Q vaporization is equal to M into L vaporization. LV for water is given by 540 kilocalorie per kg. It is also very important. Now, what about the specific heat ratio change? Specific heat ratio, it is given by Cp. It changes. On what factor it does depend, or Cv on what factor it does change. It is Q upon M delta T. It depends upon nature of the material which is we are going to use. On what nature it depends, it will be U upon M delta T. This is about the formula. Now, another question is, what about mixture of two liquids? If we are having two liquids, one is filled in a tub, its temperature is supposed to be θ1. Another is filled in this tub, its temperature is θ2. These are mixed. After mixing, we are going to fill in this portion. Its temperature is, final temperature is supposed to be θ. Now, what will be change in its temperature? How does it will change? Then heat given should be equal to heat taken, this Q1, and what about this? It is Q2. Heat given from this should be equal to heat taken from that. Then Q1 should be equal to Q2. Then ms θ1 minus θ should be equal to m dash s dash θ minus θ2. By solving this, you can go for any numerical in which final temperature is required to find. θ1 should be greater than θ2. Here it is important. Then another type of question can be asked, that how does the expansion takes place? What about the expansion? There are basically three thermal expansion. Listen, thermal expansion. First is linear, in which change in length takes place by temperature. Second is volume, in which volume takes place, change in volume takes place. And third is area, in which change in area takes place. Students, in the case of linear expansion, L2 should be equal to L1 1 plus alpha T2 minus T1. In the case of volume, we can say V2 is equal to V1 1 plus gamma T2 minus T1. In the case of aerial, A2 should be equal to A1 1 plus gamma T2 minus T1. It is very beneficial. Here alpha, beta, and gamma are three expansion coefficient. It should be beta in aerial expansion. What about alpha? It is linear expansion coefficient. What about beta? It is aerial expansion coefficient. What about gamma? It is volume expansion coefficient. What is relation between them? You can take its relation alpha is to beta is to gamma is equal to 1 is to 2 is to 3. Remember, you can take in this way alpha upon 1 is equal to beta upon 2 is equal to gamma upon 3. This is very important relation. The question can be asked, how many times one expansion coefficient with respect to another? Beta is always equal to 2 times of alpha and gamma is equal to 3 times of alpha. Remember, linear expansion coefficient is given by alpha, linear expansion coefficient is the smallest one, and another are going to be increasing in ratio 1 is to 2 is to 3. What about the change in states? Whenever we discuss about state change, this is basically of 3 types: solid, liquid and gaseous state. Listen, a pressure temperature indicator graph which shows equilibrium between these 3 states. What about this curve? It is in this way. Here there is pressure, here there is temperature. It is like that. This is O, this is A, this is B, this is C. Here there will be solid state. Here there will be liquid state. Here there will be gaseous state. Whenever liquid is going to change from, solid is going to change directly from gas, then it is sublimation or hoarfrost. So it is known as hoarfrost line. Whenever solid is going to change into liquid, then it is liquefaction and it is known as melting curve. Melting curve or ice line, it can be said. Ice line. And what about this? Change from liquid to gas. It is steam line. Steam line or vaporization curve, you can say. So these are important curves. Here there is a point. This is a point where all 3 states are remaining in equilibrium. This point is known as triple point. Here all 3 states remain in equilibrium. It is also very important point, and at particular temperature it takes place, particular pressure it takes place, particular volume it takes place. These are critical volume, critical pressure and critical temperature at which the triple point exists. Thank you very much, students. Like, share and subscribe our channel. You take its benefit. This is right time when corona is spreading. You should study at your home by using my YouTube channel. You should get its benefit. Thank you very much.